This is part 2 of 2.1 notes. As we talked about in chapter 1, a rate is a fraction that compares two quantities measured in different units. So, for example, we might say 60 miles per hour. So, in this case, we're comparing miles to hours. But in chapter 2, we want to look at a rate in a relationship. So, in this case, we call it a rate of change. So a rate of change is a rate that describes how one quantity changes in relation to another. So in this case, it's always written as the change in our output per the change in our input. We could also say change in output divided by the change in input. And since in a function or a relation we use y to represent output, and x to represent input, we might simply say the change in y divided by the change in x. So we can actually find a rate of change from our different representations of a function. So in this case, rate of change from a graph, we have two individual points, and we can figure out how one quantity changes in relation to another. So in this case, we are figuring out how is distance changing in relation to time. So as we can see, our first point has an input of 4 seconds and an output of 3 feet. Our second point has an input of 9 seconds and an output of 7 feet. So my change in my output would actually be represented by the length of this vertical line. Because notice I'm taking it from my second point to my first point, or vice versa. So the change is from 3 feet to 7 feet. Well, change in math can be described as the difference in this case. So to find this change mathematically, we would take 7 feet minus 3 feet to get a change of 4 feet. And then to find the change in our input, we can take the horizontal distance between the 2 points. So I'm going from 4 seconds to 9 seconds, so their difference, 9 seconds minus 4 seconds, would be a total of 5 seconds. So I've now found the change in the output compared to the change in the input, so I just need to write this as an actual rate. So my change in my output is 4 feet. My change in my input is 5 seconds. So the rate of change in this relationship would be described as 4 feet per 5 seconds. Now I can write this as a unit rate by taking 4 divided by 5, and that would tell me that my unit rate is 0.8 feet per second. So if I were to continue this graph, then I know the next point would be a change in seconds of 1, so I could go 1 unit to the right and then 0.8 units up to change my feet. And we'll talk about this a little bit more in the section below. We can also find rate of change from a table. So again, we need to find the change in the input compared to the change in the output. Now, don't be confused. Our change in input is the top row. However, it will still be in the denominator of our fraction. So change in the number of gallons would be 13 gallons minus 5 gallons, giving us a change of 8 gallons. Our change in cost, aka our output, would be 28.73 minus 11.05, making it a change in cost of $17.68. So I've now found the change in the output and the change in the input. I just need to write it as an actual rate. So I would say 1768 divided by 8 gallons. But once again, I can convert that to a unit rate by taking 1768 divided by 8, and that tells me that my unit rate is $2.21 per gallon. So what this means in terms of my functions, if I were to get 14 gallons of gas instead of 13, since I'm changing by 1 gallon in terms of the amount of gas, then that means I'm adding 221 to my total cost. So for 14 gallons, my total cost would be $30.94. Pause the video to see if you can find the rate of change on your own for example number 2. Once you've done that, go ahead and hit play again to see if your answer matches up. So our change in our input, aka change in time, is 5 minus 1, giving us a change of 4 minutes. Our change in output, aka our change in distance, is 240 feet. Therefore, our rate of change is 240 feet divided by 4 minutes. Or we would say 240 feet per 4 minutes, but then the unit rate can be found by taking 240 divided by 4. So we would say 60 feet per minute. One interesting thing to note here, if this example is traveling at a rate of 60 feet per minute, then we can actually go back to our function, because remember, y represents the distance from home in feet, and that means 1 minute before this point right here, they were 60 feet ahead of 75. So that means they were already 15 feet from their home when the time started. Because notice I do have that change of 60 feet compared to a change in 1 minute. Lastly, we can still find our rate of change as the slope of a straight line. So just like up here where we were comparing the vertical distance to the horizontal distance, that's essentially the same thing that we're doing to find the slope of a line. So in this first case, I've got my 2 points here and here. So my change in my outputs would be the length of this vertical line. So I can count, since each block is 1 unit, I know that this is a change of 2. However, since I am going down in my output, so I'm going from 4 to 2, it's actually a change of -2. And then my horizontal distance would be the length of the line from here to here. So I can count that's 4 units in change. So my slope, which you'll find we always use the letter M to represent, and we'll talk about that more in section 2.2, but my slope is -2 divided by 4. So this is really saying that my rate of change is -2 over 4. But then that simplifies to -1 over 2. And I can see that that is the same, because if my output changes by -1 and my input changes by 2, then I'm still creating another point that falls on the line. In our last example, we're working with the point 0, 300 and the point 12, 1500. So we can look at our vertical change, and that's a total of $1,500 minus $300, giving us a total vertical change of $1,200. So the change in our output is $1,200. And then the change in our input would be the length of this line. And as we can see, that is the difference between 12 and 0. So we have a change of 12 months. Therefore, the slope of our line, aka our rate of change, so again, that's denoted by M, is 1,200 divided by 12 months, or $1,200 per 12 months. But then we can simplify this to a unit rate, and that is equal to $100 per month. We can actually see how the rate of change or the slope of the line relates to the equation of this function itself. So the equation of this function would be y equals 100 times x and then plus 300. The reason for that 300 is because of this starting point when x equals 0. So instead of starting at 0, 0, it must start at 300, hence the addition of 300. And then what you actually do when it comes to the function of a line is multiply your rate of change by your input. And again, we will talk about that a little bit more in depth in future sections. So at this point, you are going to go ahead and try the practice questions for yourself. If you need to, make sure you go back and watch any parts of the videos that you need. Notice none of the questions are circled, meaning that you are completing all of them.